All right, so small business buys a computer for $4,800. After 4 years, value of the computer is expected to be $200. It says use linear depreciation to assess the value of the computer at a given time. Okay, depreciation means it goes down, right? What means going up? Appreciation. Okay, so technology depreciates, right? Okay, cars depreciate, all that kind of stuff. So we want to find basically an expression, right? An equation that's going to say, okay, if we know these two values, what was the computer at time of 2 years? What was the computer at time 1 year? That kind of stuff. If you guys have, has anybody recently upgraded a smartphone or anything like that? A lot of times you get online and they'll say, okay, you got your old smartphone, tell us what it is. Does the screen work? Does the battery work? That kind of stuff. Can you open it? Can you close it? And they'll tell you, okay, it's this old, that kind of stuff, and they'll provide a price point for you, right? Okay. Well, they know that price point is obviously not what you paid for initially, right? It's drastically different. But they're using that program that either Sprint or Verizon or whatever is using some type of equation for depreciation. Now, it might not be linear, okay, but it's kind of the same kind of idea going on. Hopefully the picture isn't too bad. So small business buys a computer $4,800. So at year zero, okay, year zero, we are at $4,800. Okay, so we'll write that order to pair up. Okay. Then 4 years later, so year 4, we are at, in this case it says 200. Alright, so this is going to bug me. Stay. So we're 0, comma 4,800, 4, comma 200. Okay. So we need to find a slope between those two things. Okay. So those are your ordered pairs. A lot of times, whenever, or it's not a lot of times, all the time, whenever they say an initial value, okay, and there's several ways they might verbalize that. They might say, in this case, they don't say initial value, but they say when you buy it. Well, that's times 0. Does that make sense? Okay. It's the instant you purchase. Okay. You guys go buy a brand new car. The instant you purchase it, it might be worth $32,000. But the instant you drive it off the lot, it's not worth $32,000 anymore. Does that make sense? Yeah. Hopefully you've all heard that. But that's the initial value. In this case, is $4,800. Okay. Once I become the owner, it starts to depreciate. At 4 years, okay, that's another value, another time value, and the value of that's going to be 200. Okay. So when we do this, we're used to X's and Y's, okay, but they're using a time and a value, so T and V, okay, and that's what they're talking about here, okay. That relates V in dollars and T in years, okay. So it's the same thing as X and Y. If you want to do it in regards to X and Y, and then at the end realize that my X's in my ordered pairs were actually times, so take the X out and replace it with T, and my Y's in regards to the ordered pairs are values, so take the Y out and replace it with V. Okay, that's perfectly fine. Is that all right with everyone? Okay. So let's go ahead and do it that way. If I go and find my slope, okay, so I'm going to subtract the Y value, so Y2 minus Y1, so I get what, 4,600, and then we'll divide that by 4 minus 0, so 4. Okay. So 4,600. What's 4,600 divided by 4? Is anybody do that for me real quick? How many times does 4 go into 4? Well, how many times does it go into 6? Once, and it'll leave you a 2 over, right, as a remainder. Bring the zeros down, so you got 4 and 200, right? How many times does 4 go into 200? 50, right? Okay, so 1150 is my slope, correct?
Shouldn't that be negative?
Yes. Okay. Because that was negative, right? Okay. So slope is negative 1150. Okay. So now, when we find the equation that relates this stuff, which point up there would you think is probably most convenient to plug into our y minus y1 equals m times x minus x1 stuff? Battery died, so I've only got one plug, so don't worry about it. I'll get it. It'll all work out. If not, I'll come find you. The one with the zero, okay? So y minus y1 x minus x1, it's going to be real nice with that being 0. So we'll go y minus 4800 equals m x minus 0, right? Okay? So you get y equals negative 1150 x, okay? I'll add the 4800 to both sides, right? Okay? And now, like we said earlier, our x's are really t's in the problem, so plus 4800. And our y's are really v's. So now we've got that expression that they're looking for. Now, it doesn't really matter the order. It will accept either, I've got the t coming first, but and then the constant. It will accept either format. Is that okay? Some questions, they'll give you a year. So they'll say, like, in 1999, I paid $4,800 for this thing. In 2003, I sold it back for $200. Okay, is that still basically a time value of 0 to 4 from 99 to 03? It's 4 years, right? Okay, so I can still use them as 0 and 4 as my time values if they were to do that. I could also use 1993 and 1999 and 2003 as my x values if I wanted to. It will still all work out to give me the same exact information. Does that make sense? Okay. That's a good question to talk about. I want to talk about the question that it's close to there. Something about a perpendicular bisector. 20? Yeah. All right. So find an equation of the perpendicular bisector of the line segment that joins the points 1, 6 and 9, negative 2. Okay? So the key thing that we need to realize is if I've got the point 1, 6 and 9, negative 2, so let's say 1, 6 is there, so let's call that A, and 9, negative 2, say that's B. Okay? That's my line segment, right? To be perpendicular to it, I think we all understand that it needs to intersect at a right angle, correct? But it's got to be the perpendicular bisector. What's bisector mean? Cuts in half. So where does it have to pass through AB?
Midpoint.
The midpoint of AB. Okay? So you need to find that point right there. So we're going to add the x's, divide by 2. So that'll give me what, 5? Add the y's, divide by 2. Okay, so it's going to give me 4. Okay. Oh, got to divide by 2. So 4, 2. 5, comma 2. Sorry. Okay? 6 plus negative 2 is 4. Divided by 2 is 2. So 5, comma 2 is that midpoint that we have to use. Okay? So now I need, obviously I need slope of this red line, right? Find the slope of that red line. Okay? So that's going to be y2 minus y1. So let's go 6 minus negative 2. Then we'll go 1 minus 9. So 6 minus negative 2, that's going to give me, what, 8? 1 minus 9 is going to give me negative 8. And that then gives me negative 1 for my slope, correct? Okay. That's the slope of the red line. Is that the same slope we're going to use for our line, for our equation? No. No, we're going to use the opposite sign reciprocal. What's the opposite sign reciprocal of negative 1? Positive 1. So slope you're going to use is 1. And the point that you're going to use, what point are you going to use when you plug this into that formula?
5, 2.
5, 2. Okay. So we're going to y minus 2 is equal to 1 x minus 5. I'll let you go ahead and finish working that out. Just basically multiplying, distributing your 1 and adding your 2 to both sides. But that will give you y equals x minus 3 up here. And then an image, that line should look something like that. Okay? What you got to pay attention to, and I see this all the time, is that a lot of people will do the slope correctly. They know they got to use the opposite side reciprocal, but then the ordered pair that they choose, they'll choose like 1/6. Well, if I choose 1/6 for my ordered pair, the line that I'd actually be constructing perpendicular to the red segment would be that black one, right? Okay? Because when you choose an ordered pair to plug into y minus y1 equals m times x minus x1, you're saying that the line you're creating has to contain that point. All right? So if you used A, you get that black line. Hopefully you can visualize what you would have gotten if you would have chosen B. Okay? I think those are, of the assignment, those are the ones that people get hung up on the most, just because of that phrasing, of remembering what a perpendicular bisector is, realizing that inside that information, they're hiding the word midpoint to you. Hopefully we remember that from geometry. Are there any others you guys want to talk about? Anything? All right. Like I said, that's not due until